This is homework 13. And so on number 1 on my version, it says a person leaves home and walks 2 miles west, then 5 miles southwest. So here's my little pole. And if I'm walking 2 miles west, this would be to the west. So there's my vector to the west, and it is 2 miles. Okay, and then it says 5 miles southwest. So I'm going to draw another pole. And southwest means from the south to the west. So here's south, which is down here. This is west. So from the south to the west would be there. And when it just says southwest, remember that southwest has a specific definition, and it means that this angle is 45 degrees. So that's a 45-degree angle right there, which means that this entire angle, because this is 90 degrees, 90 plus 45 would be 135 degrees. So the rest of the problem says, how far from home is she? Well, home is right over here. So it's asking you how far away from that they are. And remember, this was 5. So what I did is I used my law of cosines, and I called this x. And I just said x squared is equal to my 5 squared plus my 2 squared minus 2 times 5 times 2 times cosine of 135, because 90 plus 45 is 135 degrees. And remember, that's your law of cosines. So I got that x was approximately 6.568. So that's this right here. And then, you know, direction can be labeled in many different ways, but this one asks you for the degrees north of east. So here's where I am right now, and I'm trying to go home, and there's my little bar, and it's asking for north of east. Well, this is east. North of east is this angle right here, which is kind of a weird angle to ask for, but that's the one that they're asking for. So what I did is I found this one, because I could again use the law of cosines, and I called that one alpha, and I did 2 squared using the law of cosines is equal to 5 squared plus 6.568 squared minus 2 times 5 times 6.568 cosine of my angle, which was alpha. And so on that particular one, when I did my math, I got that alpha was approximately 12.4374. And since these two angles together are going to add up to 45 degrees, because this one is 45 degrees. So when we have our parallel lines there, that one also has to be 45 degrees. So my 12 from my 45 makes that angle that they're actually asking about 32.56 degrees. So that's what I did for number 1. Okay, so number 2, let's see what the wording on. And your problems are just like mine, except your numbers may be different because everybody's generated a different number. So let's go to the next one. Okay, so number 2. Number 2 says forces of 15 pounds and 7 pounds act on each other at an angle of 37 degrees. So I just drew out my 15 pounds and my 7 pounds, and it said they acted at each other on an angle of 37 degrees. Now, remember from your videos that I told you there were 2 ways to add vectors, and this one asks you for the magnitude of the resultant force, and resultant from your reading means that you're trying to find the two vectors added together. And I prefer the parallelogram method. It just seems to be easier for me. And in the parallelogram method, this is your resultant force, the one that comes up through there and bisects the parallelogram. And so in a parallelogram, the sides are the same. So I could use the idea that in a parallelogram, these two angles add up to 180, which makes that one 143. So I could again use the law of cosines to find that resultant. And I'll fit it to my law of cosines. And I'll do my math. And when I did that one, I got that resultant was approximately 21.0170. And then it said the resultant force has an angle of what with the 15-pound force? So it's saying this is the resultant, this is the 15-pound force that I drew. So it's asking you for that angle. So when I did the math there, I just again did the law of cosines, and I did 7 squared equals 15 squared plus 21.017 squared minus 2 times 15 times 21.017 cosine of my angle. When I put it on my calculator, my angle ended up being 11 degrees. And if that's 11 degrees and the whole angle's 37, then the other angle that they wanted, you would just say 37 minus 11, and I called that one theta. And I got that theta was around 26 degrees. So that was that one. Let's see, number 3. Let me find my page for number 3. Number 3 says, let's see, number 3 says, forces of 15 pounds and 9 pounds act on each other with an angle of 117 degrees. So this one's just like the last one. 15 pounds, 9 pounds, angle of 117 degrees. And it says the magnitude of the resultant force. So again, I prefer the parallelogram method. Found my resultant using the law of cosines. So on that one, when I did my math, whoops, that should be an equal sign. Let me erase that. So equals 15 squared plus 9 squared, 2 times 15 times 9 times cosine. And since I'm trying to find this, which I called x, these are my two sides that are around this angle. So that angle is 63 degrees because 180 minus 117 is 63. So that's the angle that you need to do in there, use to do your math. So the resultant is approximately 13.5434. So there's that one. And then it asks you on that one, it says the resultant force has an angle of, and it asks you for the one with the 15-pound force, so that would be this one. So I again use the law of cosines. So there's my math for that one, all spelled out for you. And when I put it on my calculator and I try to find my angle comes out to 36.3 degrees. So there's that. And then it asks you for the other angle. Let's go back up and look at our picture. So if the total angle is 117 degrees and the one that I just found is 36.3, I would take 36.3 from the 117 and I would get 80.7 degrees. So there's 3. Several of you asked me about number 4. So I'll give you that one. It says add the vectors u and v, and it gave you these two position vectors for number 4. It gave you this one for U and this one for V. And there were different kinds of answers that you could have, but when you add the vectors, you just add the numbers that are in the X and the Y slots there. So I'm just adding these two and adding these two and getting the addition to be this. So that part, that's the part where you get the addition. And then it wanted you to graph them. So there were a couple ways that you could do that. If I graph, remember that when you have this notation, it means that the vector started at 0, 0. So if I start at 0, 0 and go to negative 4, 2, that would be this vector. And I could graph either one of the others. If this one starts at 0, 0 and goes out to negative 3, 0, that would be right here. And then you just need to be able to connect the two. So that would be one option. Or you could do this. You could say, okay, if I start at 0, 0 and I go out to negative 1, 2, which is the other one, which would be right here, and my addition of the two vectors would be here. So there's that one. I need to be able to connect these two, which would be like that. So that's the idea behind them, is you're just trying to connect the vectors. So that's what that one looked like. And some of you said that you had a little trouble figuring out how to do the drawing. You just click on it and drag, and it lets you draw the arrows that are there. Okay, so number 5 said, let's see what it said. Number 5 says, consider the vector whose initial point is point P, which is 2, 0, and terminal point Q, which is 1, negative 5. It says find the position vector. And when you're doing the position vector, you're just doing subtraction on that. So you take this number and subtract, and this number and subtract. So 1 minus 2 is negative 1. Negative 5 minus 0 is negative 5. So there's your position vector for that one. On number 6, it said find the magnitude of the vector whose initial point is point P is 1, negative 3, and terminal point is 6, 2. So there's a couple ways that I could do that if I'm trying to find the magnitude. I could use the distance formula, or I could just subtract to find the position vector, which would be 6 minus 1 is 5, and 2 minus minus 3 is minus 5, and then take the square root of the square of both the numbers, which is basically the distance formula using 0, 0 as your starting point. That's what you're doing there. And if you'll go back and do your reading on that section, I think that it'll make more sense to you. But 5 squared is 25, negative 5 squared is 25, so this is the square root of 50. Some of you tried to put decimal answers in there, and it said to use exact answers only, which meant that it wanted you to break this down. The square root of 25 is 5, and the 2 has to stay inside. So that's the answer that it was looking for. And then the last one, number 7, let's see. Number 7 says, let me get another piece of paper here. A small plane lands at a point 183 miles east and 77 miles north of the point at which it took off. Okay, so if I draw that out, 183 miles east, directly east, and 77 miles directly north, and I'm trying to find something that combines those two directions, which means I'm trying to find the resultant vector. Since it's directly north and directly east, this is a 90-degree angle. And so I don't necessarily have to use the law of cosine since I have a 90-degree angle. I can actually use the Pythagorean theorem if I want to, because that's a right triangle. And I get that that resultant measure is around 198.54. So that's the combination of the two distances. Now, it also says in that one, find the distance the plane flew and the direction. And it asks you for the direction north of east. So, north of east, this is east. North of that would be in this direction. So, it's asking you for this angle right there. And so, I could use my law of cosines for that one, or I could use, you know, sine, cosine, and tangent. It wouldn't matter what I did to be able to find that. If I wanted to use sine, I could say sine of my angle equals 77 over 198.54, and I would just put inverse sine in my calculator of 77 divided by 198.54, and I would get roughly 22.8 degrees. So those are all of your homework problems. As always, ask me if you have questions.